Hello everyone and welcome to day 2, which is on translating lines with matrices and matrix equations. So starting off with some definitions, we're going to use matrices to represent points. So you can put x's and y's into the matrix. The key is where to put them. So if we wanted to represent a line segment with endpoints x1, y1, x2, y2, here's our matrix that we're going to put it into. It's a 2 by 2 because we've got 2 points and each point has an x and a y. So that's 2. So our x coordinates are going to go in this top row. Everything up there is going to be an x coordinate. Everything in the bottom is going to be a y coordinate. So this is x coordinates, y coordinates. So x coordinates have a row to themselves, y coordinates have a row to themselves. So if we look at our endpoints x1, y1, x2, y2, these are my x coordinates, x1, x2. So those are going to go here, x1, x2. Then I'm going to put my y's in. Here's my y coordinates. Those are going to go at the bottom of the matrix. So y1, y2. That's an x. Needs to be a y. y2. Great. And that's how I make a matrix out of points. Notice that x1 and y1 are lined up in their own column. That's the whole first point in the first column, where the whole second point is in the second column. So x is on top, y is on the bottom. First point in the front, second point in the back. So if I want to write these following points in matrix form, I'm going to take a look at my x's and y's. So I've got x, x, and then I've got a y and a y. This is also going to be a 2 by 2 matrix. So my x's are going to go on top. So this will be 4. I was going to put x1. 4 and 1. These are the x's. Where the bottom is going to be the y's. So my y's in this case are -3 and 2. So -3, 2. These are the y coordinates. Next one. Again, another 2 by 2 matrix. My x's are going to go on the top. So I'm going to have 5 and 6 on top. 5 and 6. And my y's are going to go at the bottom. So that'll be 2 and 3. That's it. If we wanted to translate the line segment, translate means move or shift. So if I just wanted to move it around on a graph, I would use addition or subtraction to do that. Oh, ran out of room. If I wanted to dilate a line, dilate means to make bigger or smaller. I would use scalar multiplication. So just multiplying the whole matrix by a number. So for this next example, we have 2 points or 2 endpoints, and we first want to write the points in the matrix. So again, I'm going to identify my x and y. So here's x's, here's my y's. So I'm going to write those in a matrix. Here's my matrix. X's will go on top, so 4 and 1. Y's will go in the bottom, -3, 2. So these are the x's, these are the y's. Now, if I wanted to translate the segment right 4 units and down 6 units, I'm going to want to add something. So I'm going to take my matrix, 4, -3, 1, 2, and I'm going to add something. I'm going to add another matrix. I'm going to make sure it's also a 2 by 2 because I can only add 2 by 2s to 2 by 2s. And I want to go right 5. So if I want to go right 5 units, right is going to be affecting the x values. And if I want to go right on the x values, I want to go more positive. When you're looking at a graph and you're going to the right, you're getting more positive on the x. So I want to add 4 to my x values. Now remember that x values are on the top. So if I want to add 4 to those x values, I'm going to want to put 4 on top. And you don't have to put the +4. I'm just putting a plus so we remember that we're adding 4. Next, I'm looking at the down 6 units. When we're talking about going down on a graph, that means that you are affecting the y values. And if I'm going down, I'm getting more negative. So that'll be subtracting 6 from those y values. Well, remember that y values are on the bottom, so I'm going to want to make sure that I'm affecting the bottom row. So I'm going to put -6 on the bottom row because I want to go down on the y's. Now all I need to do is simplify that. Remember, when you're adding, you just add the corresponding parts. So my new matrix is going to be doing 4 plus 4, that'll be 8. 1 plus 4, that'll be 5. 3 minus 6, that'll be -9. And 2 minus 6, that'll be -4. For the next one, we are going to want to dilate our segment by a scale factor of 1/2. So here's my original matrix again. I'm going to have it be 4, 3, 1, or -3, 1, 2. Just copying it from over there. If I want to dilate by a scale factor of 1/2, that just means I need to multiply the whole thing by 1/2. So multiply by 1/2. So when I'm multiplying a matrix by a scalar or by a number, I need to just make sure I multiply that whole number to every single value in the matrix. So I'm going to do 4 times 1/2, -3 times 1/2, 1 times 1/2. Hold on, let me write that better. 1 times 1/2, okay, and then 2 times 1/2. My final answer will be the simplified version of that matrix. So 4 times 1/2 is going to be whatever half of 4 is, which is 2. 1 times 1/2 is 1/2. -3 times 1/2 is going to be -3 halves. And 2 times 1/2 is going to be half of 2, which is 1. And then that's my final matrix for that one. Okay, number 3. Let's do the same thing. Again, write the points in a matrix. I'm going to write it out in a 2 by 2. The x's are going to go on top. The y's are going to go at the bottom. So I've got my x values here and here, so they're going to go at top, -2, 3. Then I've got my y values here and here. They're going to go at the bottom, -7, 5. Okay, next thing I want to do is I want to translate the segment up 4 units, left 8 units. So I'm going to take my matrix, -2, 3, -7, 5, and I'm going to add something to it. I'm going to add another 2 by 2 matrix that'll affect it the way I want it to. So I'm going to take a look at going up 4 units. Remember, when you're going up and down, that's the y value. If you're going left and right, that's the x value. So since I'm going up 4, that's affecting the y. It's affecting the y by +4. So I'm going to want to change my y row, or column, row, by adding 4 to those numbers. So I'm going to put those +4s on the bottom row. Next, I have wanting to go left 8 units. That's affecting x, because left and right is x values. And I want to go left on the x, which is getting more negative on the x. So I want to subtract 8 from each x. So I'm going to put -8 on top, -8 on top, because the x's are on top. Then I just simplify by adding each corresponding term. So -2 plus, or -8 plus -8, which is -10. 3 plus -8, that's -5. Then I've got -7 plus 4, that'll be -3. And then 5 plus 4, that's 9. Okay, for the next one, I need to dilate the segment by a scale factor of 2. So that 2, I'm just going to multiply by my matrix. So I'm going to make sure everything in that matrix gets multiplied by 2. So I'm going to end up with -2 times 2, -7 times 2, 3 times 2, 5 times 2. Just basically this 2 went everywhere in the matrix, got multiplied by everything there. So I'm going to simplify that. -2 times 2 is -4. -7 times 2 is -14. 3 times 2 is 6. 5 times 2 is 10. Great. I am going to skip B and let you guys try B on your own. Start off by writing your points as a matrix. Remember, X is go on top, Y's go at the bottom. And then you're going to translate and then dilate, just like we were doing right above. But I want to get on to these matrix equations. So matrix equations are nothing really new. I know they seem new, but really they're just basic algebra that we've been doing this whole time. So first, the matrices must have the same dimensions. So the same amount of rows, same amount of columns. Then set the corresponding entries equal to each other. And solve. Basically, find where your variable is and use that to help you figure out what you need to solve. So if we're looking at number 4, we need to find the values of w, x, y, and z. We know that these two matrices, A and B, should be equal because it says A is equal to B. So what I can do is I can set these two matrices equal to each other. So x, y, 15, 20 is equal to 3, 5, w plus 5, and 2z. Now, if I want to solve for x, y, w, and z, we can start with any one of those. I just need to look at where they are in the matrix and then set those parts equal to each other. So you can see x right here is in the top left corner. So I'm going to look at the other matrix and say which one is also in the top left corner. That would be 3. So I'm going to say x is equal to 3 because the matrices should be equal. So I'm just going to make sure that all of their corresponding parts are equal. Next, you can see that y and 5 are both in the top right corner, so I can say that y is equal to 5. Next one I'm going to look at is 15 and w plus 5. I'm going to set those equal to each other, so 15 is equal to w plus 5. Now, we're not quite done like we were with x and y because we do need to solve for w. I'm going to subtract 5 from each side, and I'm going to get 10 is equal to w. Done with that. And we still got one more. We got 20 and 2z. So I'm going to do 20 is equal to 2z. Then I'm going to divide by 2. And I get 10 is equal to z. For c, I have a lot more variables to figure out, but I'm just going to do the same thing. I know that e and f are equal, so I'm going to set these two matrices equal to each other. So I've got 5, 0, 1, 3n plus 5, negative 4p, and 6. And it's going to be equal to m, 3r minus 5, q minus 4, negative 2, negative 4, 1 minus s. Cool. So I was just rewriting these right below, but I'm making them equal. So let's go through and match up each of our corresponding parts. I'm going to start with the top left corner. And you can see that right away we know 5 is equal to m. So 5 equals m. That's one variable done. Boop. Okay, next one, we can see that 1 and q minus 4 go together. So I'm going to do 1 is equal to q minus 4. Add the 4 over. And you end up, that's a 5. So add 4 plus 4, and you get 5 is equal to q. Great. Q's done. Boop. Next one we need to do is negative 4p and negative 2. So I'm going to do negative 4p is equal to negative 2. Divide by negative 4, and you get p is equal to positive 2 over 4 because negative divided by a negative is a positive. And 2 divided by 4 can be reduced to 1/2. So p is 1/2. We found p. Done. Okay, next one is this bottom left corner, I think. Let me pick a good color. I've already been using a lot. We got 0 and we got 3r minus 5. So I'm going to do 0 is equal to 3r minus 5. First thing I need to do on this one is distribute that 3 into those parentheses to simplify this a bit. So 3r minus 15 is that once it's distributed, still equal to 0. Then I'm going to add over that 15, and I get 15 is equal to 3r. Divide by 3, and you get r is equal to 5. So we found r. That one's done. We got 2 more. Next one I'm going to do, and I'm going to pick a different color again. I'm going to do 6 and 1 minus s. So I got 6 is equal to 1 minus s. I'm going to subtract that 1 over, and I get 5 is equal to negative s. I need to get rid of that negative, so I'll divide by negative 1. And I get negative 5 is equal to s. Cool, found s. This one is the one right in the middle. You got 3n plus 5 is equal to negative 4. 3n plus 5 is equal to negative 4. I'm going to subtract over that 5, and I get 3n is equal to negative 9, divide by 3, and I get n is equal to negative 3. Cool, found all our variables. That was a lot. So for these ones, I just need to solve for the following matrices. So in this case, I need to find the missing matrix. So I have two matrices being added, and I know the solution. So what I just need to do is I need to go through and find each of those missing numbers that would make this true. So I'm going to rewrite this, 15, 9, 6, 2, 16, 20. And instead of just putting B, I'm going to add in the missing matrix that I need. It needs to have all the same dimensions, and I need to fill in all those blanks. I know it needs to equal this matrix, 13, 19, negative 2, 8, 26, 33. So all I need to do is go through and match up each part and figure out what I need to add to get to that other number at the end. So here I've got 15. I need to add something to make it equal 13. So 15 plus something needs to equal 13. I need it to get smaller, so I'm going to add a negative number. Specifically, I'm going to add negative 2, because 15 plus negative 2 will get me that 13 that I need. Next one is 9. I need to add something to 9 to make it equal 19. In this case, I would add 10 to 9 to make it equal 19. For the next one, I've got 6. I need to add something to 6 to make it equal negative 2. Again, I need it to get smaller, so I'm going to add a negative number. In this case, I'm going to add negative 8, because 6 minus 8 will give me that negative 2 that I need. Okay, next is 2. I need to add something to 2 to make it equal 8. 2 plus 6 is equal to 8, so that one was easy. For the next one, 16, I need to add something to 16 to make it equal 26. I need to add 10 to 16 to make it equal 26. And the last one, we got 20, need to add something to 20 to make it equal 33. If I add 13 to 20, it'll get to 33. So my missing matrix, B, is equal to negative 2, 10, negative 8, 6, 10, 13. Basically that whole matrix. I just rewrote it out. Okay, again, same thing where I'm just going to rewrite this D, but instead I'm going to put in the missing dimensions of my matrix that I need. And then I'm going to put plus, and I got 3, negative 7, 5, 11, and it needs to equal 11 minus 2, 5 minus 13. Okay. So let's start with my first space. I've got this space right here, and I need to add 3 to it and make it equal 11. So what number plus 3 equals 11? That'll be 8. 8 plus 3 equals 11. For the next one, I have something plus negative 7 or something minus 7, plus minus 7. Or plus negative 7 is the same thing as just minus 7. And it has to equal negative 2. So here's another way to do it that I didn't do on the other one, but you can call this one x if you want to for now. So we'll do x plus negative 7 has to equal negative 2. So I did x plus negative 7 has to equal negative 2. In this case, remember that it's equal to the same thing as just x minus 7, negative 2. I would add over the 7, and I would get x is equal to 5. So I already know that now my space is going to be filled with a 5. So that's just another way you could do it. You could set up an algebra equation for each one. But you don't have to if you want to try to do it in your head. Highly recommend if you don't know how to do it in your head, though. Next, we got this blank. We're adding 5. We need it to equal 5. Something plus 5 equals 5. That'll be 0. And last one, we got blank plus 11 has to equal negative 13. So this is another one where I would recommend maybe putting in an x. So x plus 11 has to equal negative 13. In this case, I would subtract that 11, and I would get x is equal to negative 24. So I now know that that space is going to be negative 24. When you get into those weird ones where you need to add something and it equals a negative, I think the algebra equation makes it a little bit easier. Okay, last problem, and then we're done. And I'm going to kind of move off to the side here because I'm running out of room. Again, I'm going to put in a missing matrix for R, so I'm going to draw that in. In this case, we've got 1, 2, 3, 4 spaces. And I'm adding 3, 2, 9, and 8. And it needs to equal 21, negative 12, 7, and 0. Cool. Starting with my first space, something plus 3 needs to equal 21. That'll be 18. Then my next space, something plus 2 has to equal negative 12. Again, algebra equation makes this a little bit easier. Call it x. So I'll do x plus 2 has to equal negative 12. Subtract the 2, and you get x is equal to negative 14. So I can replace my space with negative 14. Next space, something plus 9 has to equal 7. Again, put in a space if you want. Y plus 9 has to equal 7. Subtract the 9. And you get y is equal to negative 2. Replace y with negative 2. And last space, we got something plus 8 has to equal 0. So again, if you want, put a variable. Z plus 8 has to equal 0. So I'm going to subtract the 8, and I get z is equal to negative 8. Replace z with negative 8. And then that's our final matrix, the 18, negative 14, negative 2, negative 8. And that's R. Okay, cool. That's it for day 2. So I'll see you guys all back for day 3. Get that homework done, and I'll see you guys later. Bye.